This question in past paper is about standard score. Let's look at the question together. It's given that the mean score in the text is 48, and there is two students. The score of Mary is 36, while the score of John is 66. It's also given that the standard score of Mary is -2, which means that Mary's score is below the mean score for 2 standard deviation. What we want to find out is the standard score of John. To find the standard score, the first thing we need is about the mean, which is given. We also need the standard deviation of the text for the whole class. That's why what we are trying to do, we try to find the standard deviation first. And because most of the information of Mary is given, we got her standard score, we got the mean score, and also we got her original score. By setting up a formula about Mary's standard score, we can find that the standard deviation is 6, and based on this, we can find the standard score of John. John's score minus the mean score over the standard deviation, which is equal to 3, which means that John's score is above the mean for 3 SD. Part A should be a simple question. Let's look at part B together, in which required explanation. This another student, David, withdraw from the class, and his score is deleted, which means that one of the original score is deleted from the data set, and it's given that the score of David is 48, and this number is exactly the mean score of the whole class. It's a very important information to get the conclusion about the question here. Now we are asked, is there any change to the standard score of John due to the deletion of the standard score of David? So we may look at the standard score of John again, which is equal to his score minus the mean. We may think about whether the mean will change, and we may also think about whether the SD will change, because the score of John will not change here. So first, we can put down David's score, which is equal to the mean score, and this number is deleted. Because the data deleted is exactly equal to the mean, that's why the mean will remain unchanged. After that, we try to look at the formula for John's standard score. The upper part, the numerator, is unchanged. But for the SD, we have to be very careful. For standard deviation, we may recall the formula here, and originally this one terms here, which is David score minus the mean score. Originally, it should be included in the formula. After that, over n and then take square root for the standard score. But now, 48, David's score is deleted. That's why this part is also deleted. But originally, it's 0. Delete 0 means that the upper part, the numerator, doesn't really change. That's why this part is remained unchanged. And then we try to look at the bottom part. Originally, there is n student. David scores is deleted, which means that the numerator becomes m minus 1, which means that the numerator becomes smaller. If the numerator becomes smaller, the upper part, the denominator becomes smaller, which means that we divide it by a smaller number, then the standard deviation will increase. That's the observation that we need to put down here. N becomes n minus 1, that's why the standard deviation will increase here. Because the standard deviation will increase, now we divide by a larger SD, then the standard score of John will then decrease. That's why we can conclude that John's standard score will decrease here. And for senior form student, you may also interest in the marking scheme. For part A, if you are able to list out the formula for standard score, 1M here, 1A for the final answer, obviously. And then for part B, 1 marks for the conclusion, we call it 1 follow through. If you got everything correct, then you can got this 1 marks for conclusion, and 1 marks actually go to the description about the change in SD. We got 1M here.